Good night, everyone. My name is Henrik, and today I'm going to be presenting a project called Embodied AI Desktop Companion. So let me start with the project overview. So you must be asking yourselves, what are we building? So we're building a desktop AI companion with AI integrated that will evolve into a full humanoid system through progressive upgrades. So what is our core insight? Traditional VLA models, VLA stands for Visual Language Action Models, require a huge database and a lot of computing. So we are taking a different path. We are building an agent AI that will learn from every interaction, which takes me to the next part where I'm going to explain how this learning interaction is going to happen. So here we have the core concept of the learning interaction. I'm going to be breaking down how the learning process is going to happen. So let's start with and it's important to say that this process is a cycle. It can repeat all over again many times, and it will eventually increase the robot's efficiency with time. So let me start with interaction, where the robot engages with people and the environment, and voice, gestures, tasks, and feedback. And next we move to the capture, where the robot records what happened, comments, corrections, outcomes, and context. And next we move to the compressions, that instead of the robot storing everything, it distills the experience into a lesson, like summarizing a conversation into one key point. This will save a lot of memory and also will be cheaper. And next we move to the memory formation, where these lessons achieved from the previous stage are added to its knowledge bases, building a growing library of experience where it can be accessed every time to refine its behavior. And then we have adaptation, where the next time a similar situation arises, it recalls the lessons and adjusts its behavior, getting better at each interaction. And then we have the feedback loop. If the user corrects or reinforces the behavior, the robot refines its memory again. So every time the robot makes a mistake and someone goes to correct the robot will always refine its memory and its behavior. And then we move to sharing. Sharing means open source and API, where developers and robots can access and contribute to its memory system, spreading improvements across the community, creating a worldwide community as a consequence also. And then we move to evolution. Over time, the robot's personality and skills emerge from accumulated lessons, making it feel more natural and responsive. And it's important to know, just because it's open source, people can contribute to refine their robot's behavior across the board. Having a general memory where one's robot database can be transferred to another robot's database, creating a huge network of learning and improving. And then I'm going to explain about the background of our project. Let me start with the policy support. We have strong institutional backing for AI and robots, taking the fact that government and many companies are prioritizing AI and the incentives the robot industry receives. We now live in an AI world, and we know very well that where we are going, AI and robots are becoming very, very normal and also are improving. And we have the market trend. Embodied AI is rapidly expanding market, entering into commercial stage soon. The annual growth is nearly 25%. And then we have market opportunity. In this scenario where the robot industry is growing and governments and companies are prioritizing AI and robots, our project fits perfectly. Clear niches where our projects can thrive. And then I'm going to talk about next about our motivations. So I'm gonna be breaking down each problem with the respective solutions here. And let me start with the complex structure. Traditional AI robots make use of GPU cluster. You must be asking yourself, what is a GPU cluster? GPU cluster think of GPU cluster as many brains interconnected, working together to solve a problem. They are enormous and very complex and expensive. Our solution is to start with ESP32, that is a microchip, very cheap but yet very powerful. So we'll start small and cheap also. 2, we have complex system. Traditional robots use black boxes that are complex systems, such as deep learning, neural network, efficient when we aim to make a very powerful AI like ChatGPT or Copilot or DeepSeek, for example. But they lack transparency in their software. What do I mean lacking transparency? Lacking transparency means even if we have the access of the code, original code, we will never understand or figure out why the AI came to a certain decision. Our solution, once again, is 100% open source plus developer API. That is basically everyone gets to participate in the revision and improvement of our AI, making every decision that our AI comes to explainable and justifiable also, aiming for transparency and creating a community with shared goals. These 2 simplifications that I made take us to the solutions of our third problem, price. If we look into the market, robots are very expensive and cost more than 2,000 yuan. Our solution is to make an affordable entry of no more than 800 yuan. And the last problem is educational gaps. The main target of AI educational learning is SCEM. What does SCEM stands for science, technology, engineering, and mathematics students. Our solution, once again, is make an integrated approach aiming not just STM students, but also liberal arts students. For example, by drag and drop codes where students don't have to type entirely the codes from the scratch. And next, I'm going to talk about our grand vision. Here in our grand vision, there is a breaking down of our phases we're going through to achieve our final and ultimate goal. We have phase 1, that's the robot, where we have voice, vision, and AI. It's a robot able to talk, see, and use AI to respond questions and to search into the internet or database to solve simple problems of each day. And then we have phase 2, desktop robot. We have voice, vision, AI, and arm. Here is the stage where the robot starts to interact with the environment, manipulating simple objects like serving tea, carrying things like that. And then we have phase 3. voice, vision, AI, arm, and mobility. Here is the stage where the robot starts to move, where the mobility part starts. The robot will be able to interact with the environment in a wide way. For example, carrying things from one point to another, helping humans, simple things. And phase 4, we have a humanoid with AI integrated fully, meaning that the robot will interact with the environment in a 100% way, being able to walk, being able to move things, to carry things, to help surfing, and so on. And then next, I'm going to talk about the SDG goals, aligning our project to SDG goals. Here we have 5 SDG goals, and let me start with the SDG 4, quality of education. We have an integration of AI learning and robotics tool into school and universities. We have liberal arts friendly curriculum. Not just STM students will be able to learn and get familiar with robotics and AI, an affordable learning platform. We have SDG 8, decent work and economic growth. Because it's open source, allowing developers to contribute and create solutions, maybe creating some jobs where people can sell their solutions to the robot and things like that. But our first goal, we aim for a cheap platform where people don't have to pay or sell products. And then we have STM job skills development, where we use our AI to develop students from science, technological, and engineering skills, job skills. And we have AI literacy for future workplace. Each stage will be documented and can be used in the future where people want to build their own AI or robot. We have SDG 4, SDG 9, industry innovation and infrastructure. We will democratize and embody AI, making it accessible for everyone. Even in the third world countries and undeveloped countries. We have low-cost research platform affordable for robots for schools, university, and labs. Modular architecture. Each stage is independent and upgradable. Independently upgradable. In SDG 10, reduce inequalities. Accessible learning platform from basic schools to advanced projects. 95% cheaper, making learning resources viable for developing country in education, agriculture, and etc. SDG 17, partnerships. We have integration with open source community, global collaboration. We have universities and joint projects strengthening research and innovation networks. And next, I'm going to talk about the impacts that our project will be having. We have the social and educational impacts. We have first, accessible learning tools. The schools and universities could use it to teach robotics, coding, and AI without expensive licenses. Community-driven innovation, because it is open source. People worldwide could add new features, share improvements and make improvements, and make the robot smarter together. Technological impacts. We have rapid innovation without requiring a huge database at once. Developers can build apps or extensions through the API. API is a set of rules and protocols that enables different software applications to communicate and exchange data with each other, turning the robots into a platform. Like smartphones became with app stores. Transparency. Open source means people can see how AI works. From research to home, can see how AI works, reducing black box fears and increasing trust in the community. And we have the third, customization. Anyone can adapt the robot for a specific need. From research to innovation to home automation. And we have the economic market. We have first we have a lower entry barrier. Open source reduces costs. So startups and small teams can innovate without huge budgets. Ecosystem growth. If developers build apps for our robot, it could become marketplace, very similar to how Android grew in the market. Next, we have global adoption. No, we have ecosystem growth. If developers build apps, I'll talk about this one, is global adoption, because it is open source. Communities in developing countries could adapt to local needs, education, healthcare, agriculture, and so on. And then the last one is contingency plan. Each phase is independent, which means that each phase is already a finished and complete product on its own. So if later stages take longer, we already have something valuable in the market. That makes us play safely in the market while aiming higher. And when we achieve our final goal, we will be having several lines of production. And next, I'm going to talk about the monthly timeline. We have from month 1 to 2, we have the hardware procurement, A2S plus VAD driver, display driver, and basic firmware. In this stage, basically, we are getting the parts and making them work at a basic level. From 1.3 to 4, we have GLM API integration, TTT's integration, memory system, expression library, and in this stage, summarizing is making the system usable and starting to taste it. From 1 through 5 to 6, we have system integration, 3D printing, print design, testing and debugging, and documentation. Basically finalizing the system and making sure it works properly. From 1.7 plus, we have delivery support and ARM extension, R&D, that is launching, supporting, and evolving the system. And we have also our goals. We have the short-term goal, getting something working and raising money to move forward. Our midterm goal, expanding features and entering education and improving the product that works in the real world. Long-term goal, we have achieved a big growth, advanced research, and becoming global. And we have finally come to the conclusion. So what are we building? We're building a desktop robot with AI integrated that will evolve into a full humanoid. Application. Our robot is for general application, advisor, companion education, and industry, and so on. And why? This versatility according to the consumer's needs. Consumer can adapt according to its needs and its own goals and objectives. So thank you for your attention. This is the end.
Okay, thank you for the presentation.
Yes.
So now is Q&A session. So any volunteer?
Okay. What is the core innovation of Spark compared with other desktop companion robots?
Our is cheaper because we start small. Our others AI integrated systems require a huge database at once, but we are taking a different path. We are starting small. We are starting with ESP32 chip that is a very cheap and yet a very powerful chip that will allow us to play safe in the market and be very, very cheap also.
What makes your embodied AI robots different from common AI chatbots?
Our is because our can evolve through different phases. And in the market we have one product, one finished product, but we will have several lines, or we will go through several stages and phases until we reach our final goal. That is a full humanoid system.
How do you keep the price under? How do you keep the price while ensuring the performance?
Because it's an open source community, so every developer, experienced developer gets to participate in the community. So even in different parts of the world where people have their own robots, they can make improvements by their own, but their specific improvements can be shared and other people can use. So that will reduce the time while also being cheap. It wouldn't require much staff working on it or much developers working on it at once. It will require time and patience a little bit. Yes.
What is the biggest technical challenge during your development plan?
I think the biggest technological challenge will be the programming part, because although we simplify a lot by making it global, open source, we still need the main system, and this also requires a little bit of computing. Yes, that's the main technological.
What is your long-term vision for Spark in the global market?
Our long-term vision is to become a full humanoid system, able to help people on the day-by-day life, for carrying things, for example, heavy things, maybe serve tea and things like that. Yes. And helping human.
What is your ultimate dream for Spark?
Our ultimate dream is to become a global, and is to enter in a global market, and where people will have access to it, could use our robots to their specific needs, and with no restrictions. Yes.
How will you ensure data privacy when the robot interacts with users?
Because it's open source has layers of protection. So even if somebody can change our code, even if somebody can improve in their own way, we still have the main code. So people won't have to. So it's like having a recipe in the kitchen. You can take the recipe and adapt to your own way, but the recipe still remains the same. So that's the basic concept. Yes, the basic concept.
How will you make your robot stand out from similar products?
I think it's the way that we are developing it. It will be cheaper from other competitors. Our robot is 95% cheaper. I think that's a very huge difference and discrepancy when we compare to other robots in the market.
What is your team's strength?
Excuse me, I didn't understand the question.
What is your team's strength?
Our team's strength, maybe it will be collaboration and able to improve from others also, not just us. So we are open for people who want to advise us, who wants to maybe to say what we're doing wrong, and I think that's our strength actually.
So thank you for your discussion. So now's the end of the sharing. So thank you everyone to join this sharing. Thank you.
Thank you.